Hey everyone, so I want to start off this video by saying that this video is intended for students that have already taken Algebra 1. I'm going to be talking about concepts and using vocabulary words that a student who didn't have the basics in Algebra 1 wouldn't understand. So this is intended to jog your memory about how to do certain topics from algebra, but it's not meant to teach you how to do these things from square one. This video is about factoring quadratic binomials, and here are the three questions that I'm going to address. What is a quadratic binomial? What does it mean to factor? And how do I factor a quadratic binomial? So let's get started. What is a quadratic binomial? It's a quadratic with two terms. So the root bi refers to two, so it kind of makes sense that it has to have two terms. And I haven't defined a quadratic here, but it's something with an x squared term. That's the defining characteristic of a quadratic is an x squared. So we can see why both of these examples fit the definition of a quadratic binomial. They both have two terms, one term, two term, one term, two term, and they're both binomials because they both have that defining x squared term. What does it mean to factor a quadratic? Because that's what we're going to be doing in this video. It means to rewrite the quadratic as a product of terms. So we want to be able to rewrite it as something times something. So if this is a quadratic written in standard form, this is that exact same quadratic written in factored form. And this is what I mean to rewrite it as a product. This has been rewritten as a product. And what I mean by that is we have one term times another term. So we rewrote it as two terms multiplying each other. And believe it or not, even though these two things look vastly different, they are equivalent. They are the same quadratic written in two different forms, factored form and standard form. So that's what we're going to be doing all throughout this video. I'm going to give you quadratics in standard form, and you are going to rewrite them in this factored form, where it's one term times a term. So the next question is, how do we factor a quadratic binomial? Here are the steps, and I don't necessarily expect you to understand what these steps mean until I go through a couple of examples. Step one, pull out a greatest common factor, if there is one. And then step two, after you've done step one, is to look for a difference of perfect squares. If there is one, you're going to factor according to this pattern. And once again, I wouldn't expect you to understand what the heck this pattern means without a little bit of further explanation. So if you're feeling lost right now, don't worry, we'll look at examples. Here is our first example. Here is our quadratic binomial, and the instructions tell us to factor. So step one, pull out a greatest common factor. So I'm going to look at these two terms and ask myself, what is the biggest number that divides both of them evenly? So looking at the numbers first, I see 6 and 10. Those are both divisible by 2. But then there's something else that both of these terms have in common, and it's an x. So my greatest common factor, that's what I'm going to be pulling out, is a 2x. So the greatest common factor gets written in the outside of two parentheses. And then in order to figure out what goes inside the parentheses, we are dividing both of these terms by 2x. So if you divide 6x squared by 2x, you get 3x. And if you divide negative 10x by 2x, you get negative 5. Step 2, look for a difference of perfect squares. Neither of these terms are perfect squares. 3x is not a perfect square, and 5 is not a perfect square. So step 2 doesn't apply to this problem, and this is our final answer. We have rewritten this in factored form. Once again, factored form means rewriting it as a product. That's what we've done. We have this term times that term. So we have rewritten this original quadratic as a product, meaning we have factored. I hope you're wondering in the back of your head, how can we check if we've factored correctly? The answer is by distributing. So factoring and distributing are inverses. They undo each other. So if you wanted to double check that this was a correct final answer, you could by distributing this 2x back inside the parentheses. If you were to do that, you would get 6x squared minus 10x, which was the original question. So in distributing, we just undid all the work we did here, and it brought us back to the original question. All right, so because it brought us back to the original quadratic, we know that we factored correctly. Okay, so you don't necessarily have to do this, but especially when you're new to factoring, it's good to double check in your head or double check on paper that you did it correctly by distributing. All right, but this over here, right here, is our final answer. Let's look at a couple more examples. So, next one. Once again, we're going to start with step one. Pull out a greatest common factor if there is one. So if I'm looking at these two terms, there is no greatest common factor besides one, and we're never going to pull out one. So step one doesn't apply to this problem. Let's look at step two. Look for a difference of perfect squares. So you have to ask yourself, are both of these terms perfect squares? And they absolutely are, right? X squared is x times x, and 81 is 9 times 9. So they are both perfect squares, and more specifically, because they're being subtracted, they are a difference of perfect squares. So what I'm about to teach you only applies if it's a difference, subtraction, and if both of these terms are perfect squares. So how do you factor this? There's a pattern that works every time. I have it memorized. Hopefully it will become second nature to you the more you spend time factoring. It is square root of the first term, so the square root of x squared is x, minus the square root of the second term, so 9. And then there's a second set of parentheses that's the exact same, but with a plus. So this would be my final answer. This is the factored form of this quadratic binomial. Final answer right here. I've rewritten it as a product. One term times a second term. Once again, I hope you're asking yourself this, how can we check if we factored correctly? The answer is the same as it was before, by distributing. So we're going to distribute these terms inside there. Some of you might know the acronym FOIL. If you want to use that, go ahead. After you FOIL these two binomials together, you would be left with this. If you were to combine like terms, you could combine these two like terms in the middle, and they would cancel each other out. And we'd be left with x squared minus 81, at which point we would know that we had factored correctly because it brought us back to the original problem. All right, so these two things are equal. I just proved over here that they're equal. We just wrote it in factored form. All right, so this would be our final answer. This work over here was just to double check that we did that correctly. And we did. So this is our final answer. Let's look at a couple more examples. All right, step one, pull out a greatest common factor if there is one. I'm going to take some time thinking about the factors of 64 and the factors of 9, and I realize that there isn't one. So once again, step one doesn't apply to this problem. So I move on to step two, look for a difference of perfect squares. This is a difference of perfect squares. Hopefully you have your perfect squares like 1 through 200 memorized. So as soon as you see 64 and 9, you know that they're perfect squares. And once again, they are a difference of perfect squares because of the subtraction. So we're using the same pattern that we just used in the last problem, this pattern up here. It's square root of the first term, so the square root of 64, x squared is 8x, minus the square root of the second term, the square root of 9 is 3. And then in the second set of parentheses, the exact same thing, but with addition instead of subtraction. So this would be our final answer. This is the factored form of this quadratic binomial. If you wanted to check that you did it correctly, you could multiply these two binomials together. Once again, some of you might know the acronym FOIL, to double check that it would bring you back to the original question. And it would. So I'm not necessarily going to show my work every time, but it's a good habit to get into, especially when you're new to factoring. You can always check your work by multiplying your final answer back together and making sure it brings you back to the original question. Got a couple more examples for us to look at. Next one. So step one, pull out a greatest common factor. In this problem, there is a greatest common factor. Once again, I'm pretty familiar with numbers and my multiplication tables, so I can normally just come up with what the greatest common factor is by thinking about it. Some of you might need your calculators out to be testing whether these numbers are divisible by other numbers. But the greatest common factor is 16x. 64 and 16 are both divisible by 16, and then both of these terms also have an x in common. So we also have to pull out an x. The greatest common factor gets written on the outside of a set of parentheses. And then in order to get what's inside the parentheses, we are dividing both of these by 16x. You end up with 4x. 64x squared divided by 16x gives us 4x. And then 16x divided by itself gives us 1. Okay, so this is our final answer. We have correctly factored. This term times this term in parentheses brings us back to the original, but we've rewritten it as a product. Once again, I'm not going to check my work over here, but if you wanted to, you could double check that you've done it correctly by distributing this 16x back inside the parentheses. All right, one more problem. And this one's going to be the hardest one. So step one, pull out the greatest common factor if there is one. So if I'm looking at both of these terms, they both have a 2 in common. This term doesn't have an x, so I'm not pulling out a 2x like I have in some of the other problems. I'm just pulling out a 2. So the greatest common factor goes on the outside, and that leaves me with 25x squared minus 4 inside the parentheses. And now I move on to step 2. Look for a difference of perfect squares. And we notice there's a difference of perfect squares inside the parentheses. So this is the first question where we've seen step 1 and step 2 apply to a single question. So I've already done step 1 and step 2 is still relevant. I have to continue factoring this quadratic inside the parentheses. The 2 doesn't disappear. So the 2 stays there, and then this quadratic inside the parentheses gets factored further according to the difference of perfect squares pattern. So my final answer will be this: 2 times 5x minus 2 times 5x plus 2. Once again, if you wanted to double check that this was correct, you could FOIL these two binomials together and then distribute the 2. It would lead you back to the original question. All right, so our final answer for this one is right here. All right, so this has been a crash course in how to factor a quadratic binomial. Here are the only 2 steps you need to know. I hope this video has been helpful.